Okay, we're going to do some revision on solving those harder trig equations. So the first example we're going to look at is solving for theta in the interval 0 is less than or equal to x is less than or equal to 360. That should probably say theta instead. And we're solving the equation 2 cos squared theta minus cos theta minus 1 equals 0. Now, first of all, we've got here a quadratic in terms of cos theta. This actually factorises to 2 cos theta plus 1 and cos theta minus 1 equals 0. So if we then solve this quadratic, we've either got that this bracket is equal to 0, which implies that 2 cos theta is equal to negative 1, and therefore cos theta is equal to negative a half, or this bracket equals 0, which implies that cos theta is equal to 1. So I'm going to start by looking at when cos theta equals a negative half. In my calculator, I'm going to find that first value of theta. So cos inverse of negative a half, that is equal to 120. So we know that our first value of theta is 120. But we're going to have to draw our cast diagram to find out what other values of theta in our interval satisfy cos theta equals negative a half. Now, the way that these cast diagrams work, we've got C, A, S, T. In this quadrant, that's when values of cos theta are positive. In this quadrant, that's when all of our trig values are positive. Here, when sine's positive, and here is when tan is positive. We know that 120 makes an angle of 60 degrees with the horizontal. So we're going to draw that angle 60 degrees with the horizontal. So all I've done here, I've looked at my first angle and I've thought, what angle does that make with a horizontal in a quadrant? So obviously the angle 120, that is greater than 90, but if we started from any point and went round by 120, we'd be making an angle of 60 on the horizontal. Now we've got the equation cos theta equals a negative half. So we're now going to look at the quadrants where cos theta is negative. That is these two quadrants here. All we have to do now is move round our cast diagram to find our values of theta. So we're going to start off at this point on the cast diagram, moving round to any circled quadrants, and our first value of theta is 180 subtract 60, 120. Our second value for theta then, we're going to start again at the point here where we're at 0 degrees, and we're going to move round to the tan quadrant, and we get that theta is 180 plus 60, which is 240. So what we've found here is that when cos theta equals negative a half, we've got these two values of theta in that interval. Now we need to look at when cos theta equals 1. In your calculators, cos inverse of 1, that is equal to 0. So if we draw our cast diagram again, we want to make an angle of 0 degrees on the horizontal. So that is just here along the horizontal and here along the horizontal. We're looking at when cos theta is equal to 1. So we're looking at when cos theta is positive. And we are going to go round again up to those angles we've made the horizontal. So starting at 0, we're going to go up to 0. So obviously our first angle is going to be 0 degrees. So imagine we've tried to draw an arc going up to 0. Obviously we can't do that, the first angle is 0. However, for the second one, we're going to go around the cast diagram looking for the next line in that where cos is positive, which is here. So theta is equal to 360. So all of our values for theta combined, from when cos theta was equal to a negative half, we had 120, 240, and then we've just found the other two values of 0 and 360. Our second example is sine squared theta minus 30 is equal to 1/2. So we're going to again start this process by solving this equation to get what theta is equal to. So if sine squared theta is equal to, squared theta minus 30 is equal to 1/2, we know that sine of theta minus 30 is equal to plus or minus the square root of 1/2. So we've either got that sine theta minus 30 degrees is equal to 1/√2, or sine theta minus 30 degrees is equal to minus 1/√2. So if we put in our calculators sine inverse of 1/√2, we get either theta minus 30 is equal to 45, or theta minus 30 is equal to minus 45. So we're going to have to find the other values of theta and then add 30 to all of those values. Remember that we're looking for when 0 is less than or equal to theta is less than or equal to 360. So I'm going to draw my cast diagram for positive 45 first. So I've got C, A, S, T. We're making an angle of 45 degrees with the horizontal. And we're interested in when sine theta is positive, because sine theta minus 30 is positive 1/√2. So we're looking at the top two here. So starting in that positive direction, we've got theta minus 30 is equal to 45. And then going round again, we get theta minus 30 is equal to 135. Now for the negative values, so again we've got our cast diagram. We're making an angle of 45 with the horizontal. And we're looking at when sine theta minus 30 is equal to negative 1 over root 2. So we want to find out where sine theta is negative. That is in these two quadrants here. So we're going to go round our cast diagram until we meet the angle in those two quadrants. So our first angle is going to be 180 plus 45, which is 225. Sorry, that should say theta minus 30. Let's pretend that's a 30. And then our second angle is going to be the one in the quadrant on the bottom right. So here theta minus 30 is equal to 315. So if we now add 30 to all of our values to find out what theta is equal to, we've got theta is equal to 75, 165, 255 and 345.